Welcome back everyone to episode 8. We're moving into part 2 now. Having covered the AND and the OR operators, we're going to look at a few more commonly used comparison operators. So let's head on in to SQL Server Management Studio. Okay then, let's change that database quickly and we're set to go. So first of all, we're going to have a look at the not equal to operator. We've seen the equal to many times in our where clauses and in our joins, etc. And we're saying, give me everything from this table where the salesperson ID equals 2. But what if we wanted everything from the table where the salesperson ID was not equal to 2? Well, we can simply use this operator here. So it's an exclamation mark followed by your equals. And when we check our results, salesperson ID, let's sort it, make it a bit easier to see. As you can see, it starts at 3, and if we scroll on down, we're getting every single one in there, except any that are 2. Now there's two ways to write the operator. You've got, as mentioned, the exclamation mark with an equals, or you can simply type a less than followed by a greater than there, equal to 2, and you can see we get exactly the same results. There's 3 going up to 20. It's pretty simple, pretty straightforward. Show me everything from this table where the salesperson ID is not equal to 2. What if we put those on using an AND as well? And remember from the first part, when we had equals like that on the same column, we ended up with no results because it can't equal 2 and equal 3 at the same time. It needs to be one or the other. But here what we're saying, when the salesperson does not equal 2 and the salesperson ID does not equal 3, then return the values and we get results. So there's no 2 or 3, it starts at 6, 7, 8, 9 and keeps on going down the list there. So you can see that if we had an equals and then another equals on the same column, we didn't get any results, but with the not equals we return the right results in there. If we chuck in an OR, then let's see what we get with that. Let's see how things change. We're getting a sales ID, person ID of 2, and that is because it's not equal to 3. So it'll pull all those rows. And if we scroll on down, we get a salesperson ID of 3 because it's not equal to 2. So the OR operator pretty much is unnecessary when you've got two not equal to's on the same column. We're effectively getting all the results anyway, making it a bit pointless. So if we're looking at that, 70,510, if I just select everything from the invoices, we end up with 70,510 anyway, making this bit of code here in the where clause pretty redundant and pointless. But that you can see the difference between using ANDs and ORs with the not equal to operator. Quite a few differences to take into account there. So that's the not equal to, pretty simple and straightforward. Let's move on to some more commonly used operators then. So we're going to look at greater than or less than, between, in, and the not in. So we have here simply we're looking for all the invoices from the invoices table where the year of the invoice date is greater than 2015. So we just simply use the greater than sign there. So if we run that off quickly, we can see our invoice date is all 2016. because 2016 is greater than 2015. We also have the less than, so if we're staying here where the year of the invoice date is less than 2014, as you can see, all our invoice dates are 2013. And of course, if we had data going back to previous years like 2012, 2011, 2010, etc., it'll pull all those rows anyway as well. So for example, if I make that less than 2015, we're getting the 2013 years, and we're also the 2014 because those are less than 2015. Next, we have the greater than and equal to. So we want to pull the rows where it's equal to 2015 or it's greater than 2015. So instead of putting an or where you're saying whether it's greater than or it's equal to, you can just simply use the greater than equal to operator that you can see there. So if we made it greater than equal to 2015, we run that off. There's our 2015 data. Scrolling down, we start to hit 2016. So everything from 2015 plus anything greater than 2015. That's the greater than. And of course, we also have the less than or equal to. Let me put that back quickly. We have the less than or equal to, and we can change that to 2016, for example. Let's run that off. And as you can see, we've got 2013, 2014, and scrolling down, whoops, we've got 2015 and 2016 as well, because it's equal to. If we change that to 2015 quickly, you can see that we've got 2013, 14 and 15, but no 2016. So these are very commonly used operators here, very useful in these sort of situations. Now, what if we wanted to actually bring back a specific range? For example, where we want to say show me everything greater than equal to 2014, but then anything less than or equal to 2016. What we can do then is simply write it out as such and then put an and in there. So it's got to be greater than equal to 2014 and less than equal to 2016. Let's run that off quickly. So 2014, does it fulfill that criteria? Yep, it's equal to 2014. If we scroll on down, 2015, yep, it's greater than 2014, and it's also less than 2016, so that will be returned then. And of course, last but not least, we're looking at 2016, and that is equal to what we've specified there. So it's pulling all those rows that we can see. There's a slightly easier way of writing this, and that's using the between and clauses that you can see there. So all we're saying is where it's between 2014 and 2016. So thing to remember with this, with the between, is that it's inclusive. So it will include 2014 and 2016 in the result set, and of course anything in between. Let's run that off quickly. So similar to the one before, we've got 2014, 2015, which is between the two, and 2016. So just a slightly easier way of writing that out, and you don't have to put in your and there. It's pretty straightforward. We can also specify just two dates. So if we only wanted to see the invoices in 2013 and 2015 alone, but not 2014 or 2016, we can simply put the in command there, and that expects brackets, the round brackets open and close, and within these brackets you need to put your set of data separated by a comma. Now it doesn't really matter which order you put these in. As you can see, I can put it in there and it'll work in the same way. Just make sure that if you're using the in, you put the open and close brackets, because you are effectively writing in an array there. If there was just one value, you could also do that. So for example, if I did this, that would still work as well, but it defeats the whole purpose of the in, because you just simply put equals like that instead. So use the in operator when you've got an array of different things that you want to make sure you search for when you return your results. So what I'm saying here is all the invoices where the invoice date is either 2013 or it's 2015 and nothing else. So let's run that off quickly. There you go, 2013, 2015 only, no 2014 or 16 in that result set. We've also got not in, so we then specify the exact same thing, type in not in, make sure we've got the open and close brackets, and we've got our little list of integers here that we want to filter the year on the invoice date. So all this is saying is don't give me any results where the invoice date year is 2013 or 2015. So as you can see, we're replacing ors and ands, etc. with one simple functionality there. So let's run that off. So we're only getting 2014. As we scroll down, we hit 2016 only. So nothing from 2013 or 2015. So that's some pretty straightforward common operators for you. Quite a few to take into consideration there, but you can quite easily play around with the different ones as you go, as you start writing code, and use them accordingly. You've got your greater than or less than, or greater than, less than, equal to. You can also put two together with an and to give it a sort of bracket, or you can just simply replace the bracket with between and there. Or you can say, give me everything based on these criteria within a sort of set, within an array. And we can use not in as well on top of it. So quite a little bit of flexibility for you there. Just a quick example. If you remember the scenario from the first part, where we returned this bit of code here, and we had to write a bit of an or clause here with the brackets. Now there's a much simpler way of writing this based on one of the bits of code up here. If you want to give this a go, replacing the or piece here with another function that you can use within here, give that a try if you want to. Pause the video, and when you're ready we can then go through it from my perspective, and we will grab another bit of code that's more effective, more efficient from here, and replace this lengthy bit of code here. Right then, let's run this one off first. 23 rows, as you can see there. What we're going to do is comment that out. So we're looking for air freight and refrigerated air freight. So probably the best one to use here is our in. So all we simply type is and delivery name in. Remember to open the brackets, and we simply copy and paste these here. Just like that. You can put in a space or you don't need to. It completely ignores those spaces. Just make sure you've got the comma between your two strings. And that's pretty much it. Let's run it off and see what we get. 23 rows, refrigerated, air freight, etc. all the way down. So you can see here's just another easy method of writing our code to retrieve exactly the same results, and we don't have to worry about this lengthy OR piece here within these brackets. So different ways of doing exactly the same thing, some more efficient than others. So at least it'll give you a little bit more arrows in your quiver, as it were, a bit more skills in your arsenal to use when you're writing SQL code. Okay, lastly, we're going to look at the like and the use of the percentage sign here within the like functionality there. So, looking at our stock items here, what if we wanted to pull everything, all the rows where the stock item name begins with USB? Well, we then use the like keyword there, and then we'd simply, within the text that we're going to search for, we type in USB and then we put a percentage sign there. So all it's saying is, like, if it begins with USB, irrespective of what follows it, then we're going to return the result. So like here, we've got the select star and the star is select all. Within these string operators here, the little semicolons, inverted commas, this little percent sign acts as anything goes. So let's have a look at that. As you can see, stock item name, all of these begin with USB, and it doesn't matter what is after USB, it'll return the results that we're after. Now we could have done exactly the same thing with the left, stock name equals 3, where we just want to pull the left equals USB. Let's have a go at that, and we've got exactly the same results. One key difference between the two is that the left is a built-in function, so that will take a bit of computing power to go through every entry from the stock item name and check that the left 3 begins with USB, whereas this one here, where we're using the like command, is a little bit more efficient. So if you can, use the like as opposed to a left 3, for example. Go for the like, it's a little bit better, a little bit quicker. What if we wanted to find a bit of string that's somewhere in the middle of our string itself that we're searching for? So if we're looking for the stock item name and we're trying to find everything that's effectively a mug, well, we simply put the percentage sign at the front and then one at the end. So we're saying, doesn't matter what's at the beginning, doesn't matter what's at the end, just as long as it's got the word mug somewhere in it. Now, if mug is at the beginning, i.e. it doesn't have any characters before it, or it's at the end and it doesn't have any characters after it, it doesn't matter, it's still going to pull it. So that means anything, including the end or the beginning of the string we're searching for. Let's have a look at that to make it a bit more clear. And there you go, you can see mug in there. As we scroll down, it doesn't matter what comes before or after. There's mug there. Doesn't matter. We pull those rows because we're looking for mug within the stock item name. We can also use multiple percentages to look for multiple bits and pieces within our string, within the stock item name. So instead of saying if it's like shirt or it's like XL, for example, we can put it all in one line here. So no need for an or. So all this is saying is that regardless of what is starting, if it's then got shirt in it, and then regardless of what's after shirt or before XL, as long as it's got XL in it, and then anything goes after XL there. So building up quite a few anything goes within that little bit of text there. Let's run that off, see what happens, and there you go. So we've got shirt in there, and we've got XL at the end. Doesn't matter what's in between them. Again, XXL, we've got XL at the end, and so on and so on. So we've got our shirt, and we've got XL. So we're pulling those 14 rows with shirt and XL in them. Now it's important to remember the order that you place them in within your query, because what it'll do is it'll look for shirt first and then it'll look for XL. So for example, if I put XL before shirt, as you can see it doesn't pull any result because there are no rows in the table where the stock item name has got XL before the shirt part there. So remember that when you're putting together your code, make sure you put them in the right order that you're searching for. Now we can also of course put in anything goes at the start of the string, and we can put a value to end it with. So we run that off. All of these here are ending in white, every single row. So we're pulling all 21 of them, and they have to end in white. Now if within our database, our table for the stock item name ended with a space or a full stop or exclamation mark, it wouldn't pull those because it's saying it has to end in brackets, white close bracket. If of course we then put one of these in at the end, it will pull those rows. But here in this case we are saying it has to end in this bit of letters and characters there. And like with other operators, we can use a not like. So we're basically trying to say here is show me everything that doesn't begin with USB. Quite a lot more result, 213. You can see none of these start with USB. So we're pulling a lot more rows with the not like, because you're specifying pretty much one thing that you're searching for, whereas with our like we were pulling only a few rows there, only 14 rows in comparison. So you can use the not like and you can use the like itself, depending what you need to do in your code. So that's it for these commonly used operators here. Quite a few bits and pieces to take in. You've got the not equal to, you've got the greater than equal to, between, in, and of course you've then got your like. If you're looking for a bit of string within another string, stock item name, where it's like what you're searching for. So quite a few things there for you to take in. So let's have a look at another scenario and see if we can get our skills really going with that. So some dodgy items were shipped off to our retailers in Texas and they need to be recalled. The warehouse manager anxiously approaches you and asks for a list of customers from Tailspin and Wingtip Toys who are based in Texas. You need to give him the customer name and their phone number. So how are we going to go about doing this? If you want to give it a go, rack your brain cells, try it out, pause the video, and when you're ready, to compare your code. I'll show you mine and we'll take things from there. So we'll start with select start from, and what do we need to give them? The customer name and their phone number. So let's bring in our customers table quickly. Sales customers, there we go, and we're off to the customer name. Is that correct? Yep, customer name and their phone number. Let's have a look at that table quickly. Have we got a phone number there? Yes, we have. Let's use that. Here's our phone number. Brilliant. So now we just need the ones based in Texas. So how are we going to do that? Probably going to use the like in this situation. Let's have a look at our customers again. And we need to make sure they're based in Texas. So not much we can pull from here, to be honest with you. But we can see with our Tailspin Toys, we've got their state in there. NY. That's New York, etc. I think that's Kansas, New Jersey, etc., etc. So we can use that. So let's try our like. Where the customer name, like Texas maybe. Let's try that out and see how we go. So I've put anything goes at the beginning, TX, which is Texas, anything goes at the end, and let's see what we get. There you go, Texas, Texas, Texas. Let's see it all the way down, and it's simply Texas. Now, you could get the scenario where TX is within the name of the company, for example. So you might maybe want to make sure that you get the TX with, say, the brackets, just to make sure 100% that you are pulling this little bit at the end here. So that just makes sure, because you never know if TX might be actually within the customer's name itself. Let's just make sure 100% that it's got that little bracket there. And of course we get exactly the same number of rows, but that's one way to make sure that TX is not within the customer's name, because it won't have closed brackets either. But we can see that's TX bracket for all of these. So that's it, everyone, for the common operators that we use on a regular basis. Join me for the next part, where we look at the case statement. Until then, everyone, I hope you all have a wonderful day.